In the beginning of Spacex, Starship looked like one of the ugly beasts. You'll think it was welded by amateur engineers. The body was so rough, full of parches, and had an irregular cylindrical shape. Everything looked horrible, but something out of the world happened that changed the model of the Starship. So how did SpaceX remodel the Starship body from looking like a beast to something so smooth and shiny? Well, another insightful level of welding was discovered, and that's what we will unveil in today's video. First things first, let's thank His Grace. The Starship project that has been under construction for more than a decade now has finally lifted its buttocks and flew from the launch mount at Starbase Test Facility in Boca Chica, Texas, and sailed through the sky for the first time. That's huge ups. That commands confidence of the company's ability to land on the moon. Developing the Starship and getting it assembled on the launch mount all takes process, and the most important aspect is welding the different rings of the Starship body. It's a challenging but scrupulous process to achieve, since it's the welded structure of the Starship that births the giant Starship structure we all see today. And that's insane. What miraculous moves are involved in the welding process of the Starship? The golden truth about the Starship's welded body is that it wasn't thought to have it look so mighty like what we all in the 1940s sci-fi rocket that lacks surface finishing attributes, resulting to complete disorientation of the shape. At first, Elon Musk opted in for carbon fiber. It was a kind of logical plan since carbon fiber is stronger, and construction using the carbon fiber was first implemented in California. Since then, SpaceX already had most of their workforce based in California. So, everyone was shocked the moment a stainless steel Starship popped up in a small village in Texas. The reason behind the change of plan from carbon fiber to stainless steel was because carbon fiber starts melting and breaking down at temperature of around 200 degrees after the Raptor engine started firing. Therefore, it would require a very thick heat shield in order to survive the 1,600 degree temperatures or more that will be needed during multiple re-entries. Although stainless steel is heavier, but it can resist much higher temperatures, and so only a very thin heat shield would be required. And since the world's economy is gradually plummeting, with the hike in prices of gas and transportation, SpaceX had to go for what is cost-effective. And stainless steel is much cheaper than carbon, sold at just $3 per kg compared to an incredible $150 per kg for carbon fiber. But that's not all. It's not the first time stainless steel is employed in the construction of rockets. Back in the 60s, NASA made an Atlas rocket out of incredibly thin stainless steel. It was so thin that it hovered like a big balloon on the launch pad. If not that the Starship was always pressured, the Earth's gravitational force would completely crush it. But SpaceX made it much thicker. Also, it can be welded quickly using some basic and affordable welding methods. And so, SpaceX began working on the world's shiniest rocket. But for some reason, everything looked so rough and awful on the first try. The biggest challenge was to penetrate and weld the stainless steel. Each of the ring that forms the whole Starship was rolled to a number of 301 stainless steel sheets and having a thickness of 4.5 millimeters. Even with the use of stainless steel, the sad truth is that the first set of crew engineers that welded the first Starship prototype were mere tower assembling engineers and didn't have any experience with building rockets, not to talk of welding one. So, the welding standards were rough and full of unwanted details. Hence, the first Starship welders were amateur engineers that perhaps doesn't have experience in Starship welding and development. So, they did a rough job according to their experience level. But why is welding the stainless steel material so difficult, and what did SpaceX did to change the narrative? Another welding method that doesn't guarantee proper finishing was previously used to weld the stainless steel sheet together. This type of welding method in question is kind of manual, like welders will have to do it themselves, and make use of voltage passed through a metallic wire which forms a welding arc between it and the stainless steel to produce a spark that melts the electrode. The tip of the metallic wire also melts and falls into the already melted stainless steel, filling up any cracks or air bubbles. The metal wire is surrounded by a solid flux core material that burns and releases a protective gas around the weld. Similar in the case of arc welding, and this protects the weld and stops it from reacting with the oxygen in the surrounding. This method will reduce corrosion in a situation where the material will be exposed to the atmosphere, and it's a plus when you do it in a controlled environment. But the main problem faced by SpaceX, relying on this method, was that they didn't really have a proper factory, just a fairly large tent. And so, With most of the welding being done outside by welders that had no solid rocket experience, it's no surprise Starship looked so bad, ugly, and shapeless. In an application, the welds on the first Mark I prototype of the Starship were heavily corroded, with cracks and rough edges on the surface. In order to improve these welds, SpaceX started grinding them down until they were leveled with the body. However, this was a poor attempt to restore some smoothness on the Starship's body. Even though this process was done to make the weld look slightly rough, it weakens the strength of the weld. The process revealed sharp edges and tiny cracks act as pressure points, which could later lead to bigger cracks once the Starship is energized and ready to lift off. And so, grinding the surface reduces the strength of the weld. Practically, Mark I exploded when one of the horizontal welds break off and sent the bulkhead flying. So, with all these problems, SpaceX have to discover a reliable means to give the Starship surface a smooth finishing. So, they introduced a major improvement to the next Starship prototype, SN1. Each ring was now made from thicker single sheets of stainless steel 5.2 mm thickness so that the Starship structure can withstand the great force of 33 Raptor engines without breaking off. And at this moment, another method of welding, formerly called laser welding, was employed in the fabrication of the Starship sections. With laser welding, the heat is much more concentrated and goes deeper into the thickness between both rings of stainless steel, allowing the ring segments to be welded in a single pass. But to really improve the strength of each weld, another process has to be done. You see, when Starship stainless steel is produced in its factory, it goes through a process called cold rolling. This process involves passing the stainless steel sheet through a series of rollers, which compress it down and stretch out the grains in the metal. This makes the material stronger and harder, strong enough to withstand any magnitude of vibration. However, when Starship is welded, the heat causes the metal in that area to soften up. This is where SpaceX's giant planishing machine comes into play. Planishing, or hitting the welded spot down and compressing them until they match the hardness of the surrounding metal. This has the added benefit of smoothing the finished welds and improving the surface. But the question is, do you think the Starship will ever have a smooth finishing like a mirror? To answer this question, we will have to journey down to Chicago to look at the famous bean sculpture, made from several stainless steel sheets. This structure went through an 8-month polishing process, involving a crew of 24 people using many different grades of sanding grit. To have a clean finishing on the Starship body, the entire surface would need to go through this process to avoid having any visible lines around the welds. Next is another incredible welding method that made the Starship look magnificent was employed, and it makes use of auto welding robots known as friction stir welding, an upgraded version that was devised by the Welding Institute Limited. In the 90s, this technique of welding is what makes the Starship stands out from other rockets ever made in history, due to increased strength and durability requirements in modern engineering applications. The unique FWS method utilizes metals differing from conventional methods such as gas welding or arc welding. It's only a solid-state welding technique and doesn't require either of the materials being combined to be melted. This method produces magnificent mechanical properties, such as fatigue strength, tensile strength, and stiffness, as well as negligible defects in the weld region. Furthermore, this welding approach also saves material waste and offers a better look with fewer surface finishing requirements. Finally, one of the most appreciated advantages is that it has no negative environmental consequences because hazardous fumes are not produced during the entire process. What improvement do you think SpaceX should perform on the Starship surface? While they get everything ready, they have also just gotten the FAA license to release first orbital flight. Click on the video to know all of the details.